All right, so we're going to talk about normal probability distributions, and we're going to go through some of this keyword and vocab. All right, so a normal distribution is bell-shaped and symmetrical. Okay, all right, the probability is continuous. All right, the center of the bell shape is above the mean. All right, its shape, meaning the steepness of the bell, is determined by standard deviation. Okay, so our normal distribution will look like this. All right, so the very top point of this bell-shaped curve is the mean. Okay, and then what we do is we basically add a standard deviation in each direction. So the mean plus standard deviation, and then we'll do that again and again. And then to go to the left, we'll subtract the standard deviation, and then we'll do that again and again. And this should be a little bit familiar from the empirical rule, okay, that we learned in chapter 3. All right, same type deal here as the empirical rule. All right, so properties of the normal distribution. Okay, the first one we've already talked about, it's symmetrical and bell-shaped. Okay, the majority of the data is near the center. The second one, it is defined by the mean and the standard deviation. All right, third one, the total area under the curve equals 1. The area under the curve will equal the probability. Okay, and number 4, the x-axis, x-axis is a horizontal asymptote. That just means the bell curve is not going to cross that line. Okay, it's going to stay there. All right, so here's the deal. Normal curves can take on different values for mean and standard deviation. Okay, if you want to make a comparison from one set of data to another, you need to standardize the curves so that everybody has the same mean and everybody has the same standard deviation. Okay, this is called the standard normal distribution. So one difference in the word standard versus normal distribution. Okay, so the properties of the standard normal distribution are the same with one exception. The exception is this: the mean is always going to be equal to 0 and our standard deviation will always be 1. Okay, so that's the basic thing. So we're going to take x values and we're going to standardize them into something called a z-value or a z-score. So a z-value will take an x, we'll subtract the mean, and then we'll divide by the standard deviation. Okay, and this is what we call a standard score. Right here. Okay. All right, so once the normal distribution is standardized, the x-axis will be numbered from -3 to 3. And in the middle, the mean will now always be 0. And then we'll say 1, 2, 3, and -1, -2, -3, instead of having a bunch of different means and standard deviations down there. Okay.